Now we're going to go deeper into the technical side of digital twins with 4D and 3D and 4D innovation. So let me welcome on stage the CEO and CTO of Waldeck Technologies, Yoshiharu Sato. Please join me on stage. Enjoy.
Thank you. Thank you, everyone, for being here today. My name is Yoshi Sato, and I'm the founder of Waldeck Technologies. My company is specialized in radiant field technologies, mainly Gaussian splats. So this is our Gaussian splats in 4D dynamic timelapse, which was generated using our GaussianPro, an AI-powered Gaussian splat web editor for 3D and 4D digital twins. So you can visualize all these dynamic construction progresses in 3 interactive Gaussian splats. And you can see all the details, not just in the building, but also those beautiful surroundings. By the way, this is a construction project in downtown Chicago. It's a Skender project, and you can see all this beautiful Chicago skyline in the background. So just in case you were wondering who this bearded guy is, my name is Yoshi Sato, and again, I'm a founder of Waldeck Technologies. My company specializes in radiant fields, Gaussian splats, as well as AI, including transformers, reinforcement learning, and spatial intelligence for embodied AI. My company is also a Texas startup, Texas being one of the world's largest and most active venture capitals in the world, investing in startups globally. And I got 2 decades of experience in 3D graphics and AI machine learning. I was formerly a quant, working in the financial industry for hedge funds and trading firms, applying statistical and machine learning techniques on gigabytes and terabytes of multi-dimensional time series data. And GaussianPro is what my company has been working on for some time now, and it utilizes Gaussian splatting for interactive and high-fidelity 3D and 4D rendering and editing. It's a fully web-based platform, making it installation-free for users. So as a user, you will not have to install anything like Python library, PyTorch, NVIDIA CUDA, all these different versions. So it's installation-free and hassle-free. It's also got edge AI models that run directly inside web browsers. So you can do, for instance, 3D segmentation and annotation of 3D objects, or there's also real-time sharpness filter to make splatted image more crisp or sharper. And there's an intuitive splat selector that you can see in the video, where you can select all these complex geometries using a very intuitive UI. By the way, this is a botanical garden in Germany, captured by Simon Bethke. So yeah, it's a beautiful splat scene. Although my company is very small and very young, we've done several POCs already with companies like Tesla, Volkswagen, as well as CoStar Group, which is now the owner of Matterport. And those use cases include AC construction projects, also facility management of factories, or marketing, sales of real estate, and also GIS on large-scale terrains. And I'm going to talk about some of these use cases in a minute. You might be wondering why Gaussian splatting? Why not photogrammetry? Don't we already have a matured ecosystem for doing photogrammetry? To answer that question, let me quickly recap what Gaussian splatting is and how it works. So Gaussian splatting is a novel view synthesis technique for generating new images from unseen camera poses. It uses explicit rendering primitive, meaning that it's a 3D Gaussian ellipsoid. So the idea is we compose a 3D scene using millions of those Gaussians, and then we use rasterization and alpha branding, which are conventional rendering techniques and the GPU pipeline, to render all these semi-transparent Gaussians. And we project those Gaussians onto the screen, so that's why it's called Gaussian splatting. It's not Gaussian spanking or anything. And yeah, so and this is the equation. So if you're a 3D graphics engineer, so this equation might look familiar already because it's almost equivalent to the discrete volume rendering integral. The only difference here is that we get the term G2D, which denotes the 2D Gaussian density at the pixel x. But the difference is that unlike the per pixel raycasting in the volume rendering, in 3D Gaussian splatting, we use the traditional rasterization and alpha braiding. So it makes it high performance, and you can achieve real-time frame rates. Importantly, Gaussian splatting is differentiable, which means that we can compute the derivatives or gradients of the splatted image with respect to all these input parameters. You can do 3D reconstruction using machine learning on the GPU. So how does the machine learning and Gaussian splatting work? The basic idea is we compare the difference or compute the photometric loss between the ground truth image and the splatted image. And then we optimize those 3D Gaussian parameters in order to minimize those photometric loss. So those 3D Gaussian parameters include 3D position of those Gaussians in the scene, or rotation as a quaternion, or the scale, or the cutter represented as spherical harmonics or coefficient, and also the opacity. So here's the diagram of this optimization process. So first, we initially get 3D point clouds generated using SFM like CoMap, RealityCapture. Then we initialize the scene by placing a default 3D Gaussian at the location of each of those Gaussians. Then from all the camera poses, which are also estimated using SFM, we project those Gaussians onto the screen using the rasterization algorithm that we looked at previously. Then we compare and compute the photometric loss between those pairs of images. And then we can compute the what's called gradient. Then we can propagate those gradients and do what's called gradient descent, which is traditional machine learning, to progressively update those 3D Gaussian parameters in the scenes so that we can minimize the difference between those images, ground truth image and the splatted image. So that's how the machine learning in the Gaussian splatting works. And there's also one additional optimization mechanism. It's called adaptive density control, or ADC, which dynamically adjusts the number of Gaussians in the scene based on the size of the splats on the screen. So back to the question, why Gaussian splatting? So first of all, we can do 3D reconstruction without neural networks. And as we have seen already, so there is actually no AI per se in Gaussian splatting, at least by default. So it's all about traditional mathematical optimization using gradient descent and machine learning. So there is no costly neural networks, so we can do real-time rendering and editing of those 3D scenes. And there's also a low data acquisition cost because you can use almost any consumer devices such as smartphone, 360 cameras, or flying drones. And there's also a high data reusability because you can reuse the data set that you captured originally for photogrammetry. And you can also achieve a high scene fidelity using professional cameras or lighter scanners such as X-Grid's L2 Pro. And Gaussian splats also have expressive visuals, meaning that there is a wide variety of materials that you can accurately reconstruct, such as water surfaces, glass windows, or semi-transparent tree leaves, as well as fluffy animals. And scenes that were reconstructed using Gaussian splats are also holistic and immersive, because you get not just the main objects of interest at the center of the scene, but also you get all the surroundings in the background. So it's very immersive and gives you a better scene context. So those are the reasons why my company is focusing on Gaussian splats and specifically developing this Yoshiharu Pro. By the way, this is our Yoshiharu Guy. It's a dinosaur with a back fin shaped as a one-dimensional Gaussian distribution. It's a nerdy joke. So one of the major issues to which Yoshiharu Pro offers a solution is costly and time-consuming for the visualization. So traditional techniques like photogrammetry requires a large number of high-resolution images in order to generate all these interactive 4D scenes. So Yoshiharu Pro makes it easier to make such as-built 4D models thanks to 3D Gaussian splatting, which has faster data capturing and processing time. And in fact, these 4D models are already utilized in the AEC construction projects or for virtual tours in real estate, e-commerce, and cultural heritage. So you can see this dynamic 4D virtual tour of a real estate apartment. And you can see this dynamic 4D time-lapse of a construction project. This one is a Clayco project in downtown Chicago. So you can see all these dynamic intertemporal changes of this construction site. Oops, sorry. Let me go back. Oops. Okay. So yeah, in fact, we did a POC for Tesla last year. This is a as-built 4D model of their Gigafactory expansion projects, which took last year. So Tesla expanded this Gigafactory in Austin, Texas, and they documented or they captured a drone video on a weekly basis in order to capture, document, record, analyze all these construction processes. And then we generated 3D Gaussian splats for each of those videos. Then we concatenated and aligned them together on Yoshiharu Pro and generated this fully interactive 4D time-lapse, where you can observe all these dynamic construction progresses from any position, from any angle, because the underlying is the real-time 3D Gaussian splatting. And it's a great way to visualize and analyze construction progresses, and also it enhances safety, compliance, and risk assessments in construction projects, because all these 4D models contain valuable information regarding construction projects, such as those site logistics, temporary structures, and all these construction phases that can be reviewed after the fact. So yeah, this is fully interactive dynamic 4D. And we've been also doing closed beta with Skender, which is a Chicago-based construction company. And this is an as-built 4D model of their construction projects in Chicago. So as you can see, you can overlay multiple scenes together on the same screen, or you can split the screen in half for detailed progress tracking and analysis. And it greatly enhances communications among OAC, the owner, architect, and contractors. And it also helps reduce the risk of costly rework. It's important because construction companies lose billions of dollars every year due to rework. So it's vital for them to reduce such costly rework. And Yoshiharu Pro, our platform, helps them reduce such risk of rework thanks to all this detailed, high-fidelity 4D model. And those models are also useful for future modifications, renovations, as well as decommissioning of those buildings. Because again, these 4D models contain all the construction phases that can be reviewed after the fact. And since capturing reality is a tech partner to 3Dice, I should mention that we do use RealityCapture for aligning all these different point clouds together in order to generate these 4D models. And we use DCPs or ground control points to align multiple point clouds at the same time. And those DCPs are either geo-referenced with actual locations, or they have synthetic Euclidean coordinates. And you can just you can align all these point clouds together in a single click on RealityCapture. So it's a great tool and software for us to generate the 4D time-lapse models. And another major problem to which GaussianPro offers a solution is scene understanding and 3D reconstruction. So 3D reconstruction inherently lacks scene understanding, whether it be point clouds, photogrammetry, 3D actions, because the other one is just a monolithic collection of static points, meshes, or Gaussians. And it makes it difficult to rapidly make informed 3D digital twins, for instance, museums with lots of exhibitions, or retail stores with a bunch of products or items. So GaussianPro utilizes vision transformers, or AI models, for dynamic 3D object segmentation. And everything runs inside a web browser, thanks to the latest web technologies, such as WebGPU and WebAssembly. It achieves a full web-based edge AI inferencing. And this means that the platform is fully installation-free for users. And for us as a service provider, there is no expensive GPU server cost, because all the GPU processing takes place on the client side. And on GaussianPro, you can also do detailed segmentation of complex geometries. It's got an intuitive UI for manual 3D segmentation of objects like MEP, pipes, and cables at the construction sites, or HVAC equipment, heating, ventilation, air conditioning. And it can be also utilized in facility management of complex machinery and equipment. You can also use it for forestry, where you need to segment and keep track of all these different trees, vegetation, or plants. So it's got an intuitive UI where you can just need to drag along the object. Then you can segment Gaussian splats very, very easily. Although GaussianPro is still in early beta, there are other useful features already, such as object import and export from other Gaussian splatting scenes or from generative AI. So you can generate highly detailed 3D Gaussian splats from just a single image, and you can import that 3D Gaussian into your scene, as you can see in the left video. So this is a generative model. It's called Trellis, and you can generate these highly detailed 3D Gaussians from a single input image. And on GaussianPro, you can segment, for instance, the scale of the Triceratops, and you can remove it and then import and replace it with the scale of the T-Rex. So yeah, that's something you can do already on a platform. And also we got a 3D Gaussian sharpness filter, which works in real time to enhance the splatted image in order to make the splatted image more crisp or sharper. Because one of the common complaints of Gaussian splats is actually blurred images. So this filter dynamically enhances these splatted images. And also, yeah, there's a camera animator where you can create smooth camera fly-throughs. And also, we are working on large-scale scene and rendering, which we are working on to make a digital twin of a city. Those large-scale, city-scale scenes. Or you can also do it for doing GIS. So, and we are also working on other more useful features. So that's it. Thank you very much, everyone, for listening. And if you're, yeah. And so if you or your company is interested in doing a POC or early beta, yeah, please feel free to reach out. Thank you.
Yoshi, thank you so much. Let's give it up for Yoshi one more time.
Thank you.
Thank you so much. Well done. Well done.